Okay, y'all. I think I figured out what the focus issues might be with this camera. I had a low light situation in my apartment, so I had two huge fluorescent lamps over here and there that put out a lot of heat as well as light. So whenever you notice when I would ever move, it would flash because I recorded because I wanted to see, and that affected the autofocus. So now I don't think I need those lights. I just have one up there, and I have my living room and door light done. So very effective, I think, right now. We'll see. Anyway, I wanted to go over the asynchronous homework problem that y'all probably encountered and were having difficulty with. And sorry about that. Not that one. Fumbling. This one, number 22. All right, and the problem with this one is that you wind up with a quadratic denominator. If you factor out the 2, you get a 2 and an x minus 1, right? Now, I think that this should have been minus 4. I think that was intended. The source, I got this from some college source. I don't think they intended this to become the cubic equation, so I think this should have been minus 4. But in reality, these problems do happen. So let's look and see how we could solve this, right? So I posted, you guys probably figured this out. I'm going to have a going over the homework, and I'll post, solutions. I think the textbook homework, I'll just do live in class. I believe I have enough time, but if not, I'll look at it a little later on today, and I'll make some video explaining and give you the solutions that way. But I think there's probably only going to be five or six that y'all might need. We'll see, but that's usually what it is. So anyway, these are 3 picks that I created, and so if we zoom here, and then we go down, of course, this is going to be pain in the butt a little bit. So here's the solution. Okay. Now there's some things here that I'll write on the board in a minute. I'll go through this whole problem with you guys. So notice that the first thing we want to do is get that common denominator, which would be the least common multiple. And notice that right here, I went ahead and factored out the 2 because you don't really need to multiply every single thing. So you just want to make sure you get clear with what it is you want to multiply. So notice over here the LCM. Now, you can just make that x squared minus 4. But technically, there are 3 binomial factors. 2 are the conjugates from the difference of 2 squared. Okay, so here's the equation I got. Now I've checked this thing 10,000 times. I'm exaggerating, probably about 8 times. And I'm really sure that this is what we get. And then when you multiply that out, you get it equal to 0. Okay? And just, before I do it on the board, when you have this equal to 0, sometimes you can factor by grouping if you get the ratio of adjacent terms to be the same. That's what I'm doing over here. So if that negative 12 over 10 is the same as 54 over negative 46, that means there's a common factor in the adjacent terms. Now you could switch these middle terms. You could put the negative 46x as the second term and the negative 12x squared as the third term. And then the adjacent term coefficients would be these. Either way, they don't work. So you cannot factor this out by grouping. Okay, so what I did is I went to Desmos. I put this equation equal, and the x-intercepts would be, and there they are. I'll show you all that in a minute. Okay. So that would be where, that would be under the Desmos tab, but of course, this little top thing, so that would be right here. So you can see what I did is I put that equation over here, and these are the solutions. Because if this equals 0, that means the x-intercepts of the polynomial. Okay? All right, so here's our problem. And so we want our LCM to involve the 2 dx minus 1, and then I'll just leave this as x squared minus 4. Okay, so when you multiply that top and bottom here, you're going to get everything multiplied to the 5.
Trailing after 7 innings this season, they are 0-16.
And then when you multiply top and bottom here, it's just going to be the x squared minus 4.
Right now, only a 3-run.
And then when you multiply top and bottom here, you're just going to multiply the 2 and the x minus 1.
Velasquez has gone 1 for 2 with a bunt for a single in the third.
Okay, now that's just the numerator. So the denominator down here would be the LCM, and denominator over there would be the LCM, right? Now you want to do the FOIL here first and save the 10 for last. Right, so 10 x times x squared minus 1 times x squared minus 4 times x, and then negative 1 times negative 4. And then multiplying this out, minus 2x squared plus 8. Be careful, I made that mistake earlier on the call it. Minus times a minus. And then this is going to become 6 times x minus 1. So you get that. All right, so you're going to get a 10x cubed term. You're going to have a minus 2x squared over here, and you're going to have a minus 10x squared here from the plus 10x, minus 10x squared here from the distributed property. Okay, you're going to get a negative 40x here, negative 40x here, and then when you subtract the 6x, that's going to become minus 46x. And then you're going to get a 10 times 4 here, and then you plus the 8, and then when you're going to add 6. Right, so that's a whole lot of stuff doing in the head, but you know, we're in trig calculus, right? We can handle equations. Didn't realize the sound was off. Sorry, y'all. That's such background baseball. I don't even realize it's on. I hope that wasn't a hindrance. So we got to solve this. Now, again, if this was something like 10x cubed minus 20x squared minus 46x. Notice that these are doubled. Okay, so what's doubled this? Looks like it's 92. Okay, then we would have an option here. We could factor out the 10x squared. And then we can factor out the negative 46. And you should be getting the same thing in parentheses, so then you could solve that using the zero product property. So this would become equal to 0, that would become equal to 0. So 2 would be a solution. Well, actually, we'd have to exclude 2 because notice in the original equation it causes a division by 0 issue. So the 2 we get from solution of this would be extraneous. And then here you'd have this equal to 0, so 46 divided by 10, take the square root of that. So plus or minus the root of 46 over 10, plus or minus the root of 4.6. So that's what we could have done. Let me get something to erase. But let's all shed a tear. Can't do that. We have to solve this hard problem. Now, there are ways of solving cubics. What we're going to do is just use decimals. I already pointed that earlier. But if you're curious, what did we do before computers? How the heck did we solve this? What we did is we used synthetic division so we can kind of determine where the roots are. So like, say we know that we're right around -1. Right, we know we're in between 1 and 2, and we know this is in between 2 and 3, okay? Well, what they used to do is they would guess, okay, 3 is right here, let's do a slope, and then guess right here, and then gradually approximate. So they would do something like this, right? And each of these would get closer and closer. It's complicated. If you're curious, look up Newton's method. You're going to have to learn something called the derivative, which I normally would teach y'all, but because of the way we're handling the topics issue, I don't know if I'll go over derivatives with you guys, but I would have showed this to you. We'll see. Anyway, you don't need to worry about that. Just use Desmos, put this in, find the x and y intercepts, and just like I showed y'all, there's the solutions. All right, y'all take it easy.